In this video, we will talk about trig equations. This section goes back to our chapter 1 of quadratics, very much similar to factoring. So we will be solving for x on domain of 0 to 2 pi, giving your answers in exact values. That means don't use calculators. So we're given 2 sine squared x plus sine x equals to 0. In these two terms, we have sine x in common, so that's what we're going to factor out. Sine of x, then we're left with 2 sine of x plus 1 is equal to 0. When two things are being multiplied and equal to 0, that means either sine of x is equal to 0 or 2 sine of x plus 1 is equal to 0. We know sine of x is equal to 0 on 0, pi, 2 pi on this domain of 0 to 2 pi. 2 sine of x plus 1 is equal to 0. So if we subtract 1 and divide it by 2, we get sine of x is equal to negative half. Sine is negative. All students take calculus. So it is negative on third and fourth quadrant. Then think about what angle will return the sine value of negative half. It's at 7 pi over 6 and 11 pi over 6. So the answer to question A will have 0, pi, 2 pi, and 7 pi over 6, 11 pi over 6. Moving on to the next question, we have 2 cosine squared x plus cosine of x minus 1 is equal to 0. Let a to be cosine of x. So we have 2a squared plus a minus 1 is equal to 0. This is a quadratics, and a lot of times in this section, these quadratics will be factorable. So we have 2a minus 1, a plus 1 equals to 0. That means 2a minus 1 is equal to 0, or a plus 1 is equal to 0. Solving for a, we get a is equal to half, or a is equal to negative 1. Now, plug back in what a is equal to, which is cosine of x. Cosine of x is equal to half. Where is cosine half? All students take calculus on first and fourth quadrants. Cosine is half on pi over 3 because of 1, 2, 3, 3, 2, 1 over 2. That's the unit circle. Cosine is the x value, so it's the first angle closer to the 90 degrees. So that must be pi over 3. Another one is a 5 pi over 3. Then we think about where is cosine of x equals to negative 1. X must be pi. So in this question, we have 3 answers. Given a domain from 0 to 2 pi, we want to solve for x, given an equation of sine x plus cosine of x is equal to square root of 2. First, we are given sine of x and cosine of x in one equation, so this is not solvable as it is. However, if we square both sides, we get sine squared x plus 2 sine of x cosine of x plus cosine squared x is equal to 2. Because we will be foiling, we will get 3 terms on the left side. Sine of x plus cosine of x is equal to 1. So 2 sine of x cosine of x plus 1 is equal to 2. So if we subtract 1 on both sides, you would get 2 sine of x cosine of x is equal to 1. But 2 sine of x cosine of x is equivalent to the double angle formula for sine. So sine of 2x is equal to 1. This is now going back to section A of this chapter. You are given a domain from 0 to 2x, but now your x has become 2x. So we will be multiplying 2 on both left and right. So now our new domain will be going from 0 to 4 pi. That means you're going around the unit circle twice. So sine is equal to 1 on pi over 2 and 5 pi over 2. So first time you go around the circle will be pi over 2, and then adding 2 pi onto pi over 2, that's 4 pi over 2, you get 5 pi over 2. 2x is equal to these two values. In order to solve for x, you divide it by 2. In other words, you're multiplying by half. So x is equal to pi over 4 and 5 pi over 4. Something to keep in mind is checking your work. When you plug in pi over 4 for your x, you get sine of pi over 4, which is root 2 over 2, cosine of pi over 4, which is another root 2 over 2. So you have 2 root 2 over 2. So cancels out, and you're left with root 2. So this checks and this works. When x is equal to 5 pi over 4, 5 pi over 4 is on the third quadrant. Therefore, your sine and cosine value must be both negative. So sine of 5 pi over 4 will be negative root 2 over 2. Cosine of 5 pi over 4 will be negative root 2 over 2. So you're left with negative 2 over root 2 over 2. 2's will cancel out again, but this time you're left with negative root 2. Negative root 2 is not equal to root 2, so this doesn't check. So the only answer on this problem will be pi over 4.